In this video, we're going to look at infinite geometric series and sequences. So an infinite geometric series is just a geometric series, but the terms go on up until infinity. So previously, when we were looking at geometric series, like say 1, 2, 4, 8, and so on, usually we considered some value, we considered the nth term. We assume that it was ending at some point. But when we consider an infinite geometric series and a sequence, so series just means we're adding together the terms, right? So it's gonna go on and on until forever. So sometimes, for example, if you have, say, 1 plus half plus 1/4 plus 1/8 and so on, you can actually calculate the sum. The sum of this infinite series is a finite value. So how do we know when the sum is finite or infinite? So that is dependent on the common ratio. And if we take the absolute value of the common ratio, if this is less than 1, then this guarantees convergence. So if you don't understand what this means, this expression here, then what I'm saying is if my r value is between 1 and -1 and r is not 0, but if my common ratio is not equal to 1, is less than 1, and it's bigger than -1, then I'm gonna, even if my geometric series is infinite, goes on to infinite terms, I'm gonna be able to calculate the sum. And why is that so? So let's look at the formula for the sum of n terms for a geometric series. So that is a to the power r to the power n minus 1 divided by r minus 1. Or another way to write it is a 1 minus r to the power n divided by 1 minus r. So now, what happens when we consider the limit? So basically we want to think of what happens when n becomes bigger and bigger and bigger. So n tends to infinity. So limit as n tends to infinity. As n gets bigger and bigger and bigger, what happens to our sum? Well, remember, I said the condition for convergence was that my r value is between 1 and -1. And if r value is between these two, if you raise bigger and bigger numbers, so if your r is say 0.9 and you're raising it to 2, 3, 4, it's going to get smaller and smaller and smaller. And smaller and smaller. And another way to look at it is if you know the graph for exponential functions. So this is the graph for an exponential function when a is less than 1, right? So if a is greater than 0 and less than 1. So this is how it looks like. And basically the idea is that the bigger your n is, the bigger your power is. And this is a graph for a to the power x, right? So the bigger the power is, the closer it's getting to 0. So therefore, when you take the limit as n tends to infinity, r to the power n, this is going to collapse to 0. So we have a divided by 1 minus r. So that is the sum of an infinite terms for a geometric series. And this is the condition for convergence. So if it does not satisfy this condition, then we say that the geometric series diverges. All right, so now that we have the ideas down, let's do some questions. All right, so question 1. So I'm gonna do A and D, and I'm gonna leave B and C for you. So A is just 2 plus 2 over 3 plus 2 over 9 plus 2 over 27, and so on. So a, the first term is 2, our common ratio is 1 over 3. If you divide second term by first term, you're going to get 1 over 3. So the sum of an infinite amount of terms is going to be 1, it's going to be a divided by 1 minus r. So it's going to be 2 divided by 2 over 3, and that is 6 over 2, and that is just 3. So this just adds to 3. And let's look at question D. And actually, these are very short questions, so I'll do B and C as well. So B just says 1 plus 0.1 plus 0.01 plus 0.001, and so on. So your first term is A is 1, and your R is just 0.1. And now the sum of infinite amount of terms is going to be 1 divided by 1 minus 0.1, right? A divided by 1 minus R. So 1 divided by 0.9, and that is 10 over 9. And 10 over 9, you can also write it as 1 over 9. So it's the same expression. So C says, C is just 40 minus 20 plus 10, and so on, right? So your first term is 40. Your R is going to be negative 20 divided by 40. So that is negative half, right? And therefore, your sum to an infinite number of terms is going to be 40, that is A, divided by 1 minus of minus 1 by 2. So that is 40 divided by 3 by 2, right? So that is 80 by 3. And if you want to write it as a mixed fraction, then you can divide 80 by 3. So that is 26, 2 over 3, I believe. All right. And let's do D. So D just says negative 64 plus 48 minus 36 plus 27, and it goes on. So our A is negative 64. Our common ratio is going to be 48 divided by minus 64, right? T2 divided by T1. So 48 divided by minus 64 is just negative 3 over 4. It's negative 0.75. All right, so our sum to infinity number of terms is going to be A divided by 1 minus R. A is negative 64 divided by 1 minus of minus is going to be plus 0.75. And this is going to be negative 64 divided by 1.75, right? And we can actually write 1.75 as 1.75 as a fraction would be 7 by 4, right? So actually we have negative 256 divided by 7, because you can take the reciprocal and multiply 4 at the numerator. So you would get this expression, and that is just negative 36 and then 4 over 7. So that is your answer when you write it as a mixed fraction. So I'm just writing it as a mixed fraction to match the answer given in the textbook. All right, so we're done with question 1. So the first 4 terms of a geometric progression we are given are 1, 0.5 squared, 0.5 to the power 4, 0.5 to the power 6. Find the sum to infinity. So sum to infinity is just going to be first term, A, divided by 1 minus what is the common ratio? Well, it's 0.5 squared. Remember, you want to divide. And when you divide, you get 0.5 squared. So 0.5 squared is just 0.25. So in the denominator, you have 0.75. And when you simplify, you're going to get 4 over 3. Because 0.75 is 3 over 4. And you can multiply by 4 on the numerator and the denominator. And these cancel out, so you get 4 over 3. All right. Question 3. The first term of a geometric progression is 8. The second term, which is AR, is equal to 6. So what is R? Well, I know A is 8, so 8R has to be 6. R has to be equal to 6 divided by 8. So we're just using what is given, right? So I have AR, second term is 6, so I just substitute 8 here. 8R is 6, 6 by 8. So 2 3s are 6, 2 4s are 8, right? So we have R is 3 over 4. And the sum to infinity is just the first term divided by 1 minus 3 over 4. 1 minus R. So that is 1 over 4, and that is just 32, if you simplify. All right. So the first term is 270. AR cubed is 80, right? So this is a type of question that we've seen before. So AR cubed is 80. A is 270. So we can divide. A's cancel out. I have R cubed. And 8 divided by 27, that is 2 cubed divided by 3 cubed. 27 is 3 cubed. 8 is 2 cubed. So you get R is equal to 2 over 3. So this is a similar question we have done in the previous videos. And now what we do is we want the sum of infinity terms, right? So this is the common ratio. And the sum of infinity terms is just 270, which is A, divided by 1 minus 2 over 3. 270 divided by 1 over 3. And that is just 0, 1, 810. All right, moving on to question 5. So write the recurring decimal. So the dots mean which terms are repeating. So we have 0.57 dot. This just means 0.57, 57, 57, 57, and so on. So now we want to express this as a sum of a geometric progression. Well, let's think about it. What is the expression that is repeating? 57, 57, 57 is repeating, right? So how do I write this 0.57? How do I write just this part, 0.57? Well, that is just 57 divided by 100, right? Plus, now I imagine that let these be zeros. How do I write the next 57? Well, that is just 57 divided by 1, 2, 3, 4. So 10 to the power 4. 100 is 10 squared. And now I'm done with this. So 57, how do I write? I have 1, 2, 3, 4. I need to take 1, 2, 3, 4, 5, 6. So it's divided by 10 to the power 6, right? So you get the idea of how to write this as a geometric series. And now this is going to be your expression. That is 0.57 repeating. So you just want to divide them and see how you can write the repeating terms divided by 10 to the power of something. So now, once you have done this, you can factor out the 57, and you can write it as 1 over 10 squared plus 1 over 10 to the power of 4, plus so on. And this is in geometric series. 57. So my first term, A, is just 1 over 10 squared. And what is my common ratio? Well, my common ratio looks to be 10 to the power negative 2, right? Or 1 over 10 squared. If I multiply my first term with 1 over 10 squared, I get the second term. So 1 over 10 squared. So let me multiply by 100 on the numerator and the denominator. The reason for doing so, if I multiply by 10 squared, then these are going to cancel out. So I have 1, and if I multiply by 10 squared, on the denominator, I have 10 squared minus 1. Because these cancel out, and I get 10 squared here. So now I have 57 divided by 10 squared is 100 minus 1 is a 99. And if you think about it, both of these are divisible by 3, right? So if I divide by 3, then I have divided by 33, and on the numerator, I have 19. So your answer has to be 19 by 33. Right? So use your answer to show that can be written as this. So we just want to look at the sum of the infinite geometric series. So if you're not given the answer, if it's not a proof question, then how do you know the answer? So let me show you another way. So 0.5757 is repeating. So let's just call this x. Now, I want to separate the repeating units, right? So 5757 is repeating. So let me just multiply by 100. 100x is going to be 57, 2 decimal points, 0.5757. And now let me compare this with x, which is 0.5757 all the way up until infinity. If I subtract these two equations, I get 99x is equal to 57 minus 0 is just 57. And these will cancel out. These are decimal places in the same position. So 5 and 7 will cancel out. And then I have x is equal to 57 over 99, which is just 19 by 33. So that is another way to check your answer. All right, so let's do some more questions. So question 6, the first term of a geometric progression is 150. A is 150. The sum to infinity is given to be 200. So sum to infinity is just A divided by 1 minus R. And that is 200. And we know what A is. So 150 over 1 minus R is equal to 200. Now we can solve for R. 150. If I multiply 1 minus r on both sides, I get 200 minus 200r, right? So I get negative 50 is negative 200r. Now I'm doing the algebra very quickly here. These will cancel out, and I get r is equal to 5 by 20, which is just 1 over 4. So that is your common ratio. So you can think of it slowly on how I did it. I multiplied by 1 minus r on both sides. These canceled out. And on my right-hand side, I got this expression. And then I used some algebra to get r is equal to 1 over 4, which is 0.25. And it's find the sum of the first 4 terms. Sum of the first 4 terms, well, now that it's not we're not considering to infinity anymore, we're going to use the same formula that we used in the previous video. So that is going to be a times r to the power n, r is 0.25, to the power n 4 terms minus 1 divided by 0.25 minus 1. And if you use your calculator to simplify this, you get 199.21875. So that is your answer. Question 7. The second term of a geometric progression, which is t2, is equal to 4.5. So t2, remember, is AR. And the fourth term is 4. Sorry. Okay, I misread the question. And the sum to infinity is 18. So sum to infinity is 18. Find the common ratio and the first term. All right. So I know AR is 4.5, and I know sum to infinity is 18. So A divided by 1 minus R is equal to 18. And A, if I multiply by 1 minus R on both sides, or A divided by 18, if that is easier for you, is 1 minus R, right? I take this to this side. So A should be equal to 18, 1 minus R. A is equal to 18 minus 18R. And now I can substitute this in my first equation. If I substitute it here, AR, I get 18 minus 18R times R is 4.5. So I have 18R minus 18R squared is equal to 4.5. And this is a quadratic equation. So if I take all terms to one side and simplify, I get 18R squared minus 18R plus 4.5 is equal to 0. And now I can use the quadratic formula. So R is going to be minus B plus or minus the square root of B squared minus 4AC all over 2A. So that is minus of minus 18 is going to give me 18. Plus or minus the square root of 18 squared, 324, minus 4 times A is 18, times 4.5, 324. So that is going to give me 0, right? 18 all divided by 2 times 18. So we have a single root, and the root is 1 over 2. So R is equal to 1 over 2. And I can use my first equation to calculate A. So A times 1 over 2 is 4.5. So A has to be equal to, if I multiply 2 on both sides, 9. So A is 9 and R is half. All right. So we are done with question 7. 0.5 and 9. So let's move on to question 8. Write this decimal, as a fraction. All right, so we have 0.315151515, and so on. So let me write 0.3, and then I have the repeating unit of 1515. So 0.3 is just 3 divided by 10. And then I replace 3 with 0. So how do I write 0.015? Well, that's 15 divided by 1,000. And 1,000 is just 10 to the power 3. Plus 15, now I replace this by 0, 0. How do I write 10 to the power, how do I write 0.00015? Well, that is just 15 divided by 10 to the power 5, right? 15 divided by 10 to the power 5 would be, you have this, and then you take 0 3 more positions. So you start with 15, you have a decimal point here, you take it 1, 2, 3, 4, 5 steps, and then you have a 0 here. So 0.0015, which is exactly what we need. So we have 10 to the power 15 divided by 10 to the power 5. And this will go on. So I have 3 over 10 from my first term. And from my second term onwards, I have 15 common. And I have 1 divided by 10 to the power 3, plus 1 divided by 10 to the power 5, plus 1 divided by 10 to the power 7, and so on. Because if you look at it, your common ratio is 1 over 10 to the power 2. So now that we have that, 3 divided by 10 plus 15, I'm going to sum this to infinity because this is going on up until infinity. So the sum of this to infinity is just 1 divided by 10 to the power 3, that is just a, divided by 1 minus what is r? R is just 1 over 10 squared, right? Think about it. If you divide this by this is the expression that you are going to get for your value of r. So that is 3 over 10 plus 15. And if I multiply by 10 to the power 3 on the numerator and denominator, I get 1 divided by 10 cubed minus 10. And I'll leave you to think of how we got to this point. I'll leave you to check the algebra for yourself. So 15 divided by 1 over 990. So that is 3 over 10 plus 15 over 990. So what do I need to multiply 3 with to get? So I want a common denominator. And I can multiply 10 with 99, right? To get 990. So 3 times 99 plus 15, that is 312 for my numerator and 990 for my denominator. And if you simplify this fraction, you get 52 divided by 165. So you can leave it at either, but it's recommended that you simplify. So this is the expression as a fraction. Now, can we use the same trick that we used before, the one I showed you? Yes. So x can be 0.3151515, and so on. And let me multiply this by 10. 10x. So if I take one decimal here, I get 3.151515, and so on. Well, multiplying by 10 is not going to work because I want things to cancel out, right? So x is 0.3151515, and so on. What if I multiply x by 1,000? If I multiply by 1,000, I'm going to have to take it 3 positions. I get 315.151515. So you want to multiply by a value that makes sure that when you subtract these two things, things will start canceling out. And if I multiply, well, things are still not canceling out because we have a 3 here. So what if I multiply my second expression by 10? I get 3.15, and now I can safely subtract. So I would get 990x 312, right? If I subtract 315 minus 3 is 312, and these will cancel out. So I get x is equal to 312 divided by 990. So this is a bit quicker actually, which is the same thing, 52 divided by 165. So whichever method you prefer, but it's preferred that you do use your idea of geometric sequences and series. All right. Question 9. The second term of a geometric progression, which is AR, is equal to 9. And the fourth term, which is AR cubed, is equal to 4. Given that the common ratio is positive, so r greater than 0, so how do we find? I am given AR and I'm given A. So if I divide AR cubed by AR, I get 4 over 9. And remember, 4 is just 2 squared, 9 is 3 squared. So A and A cancelled out. R cubed divided by R is R squared, is 2 squared over 3 squared. And because R is positive, R has to be 2 over 3 when you take the square root. So that is, and I can substitute it here. A times 2 over 3 is 9. So A is just 27 by 2 when you solve it. And 27 by 2 is just 13.5. So I know R, I know A, and the sum to infinity. So sum to infinity is just A, which is 27 by 2, divided by 1 minus R, and R is just 2 over 3. And if you simplify this, that is just 27 by 2 times 3 over 1. So 54, that is 81 over 2, I think. $40.5, yes. So this is your answer. Fairly simple. All right, let's move on to question 10. The third term of a geometric progression, T3, is equal to 16, and T6 is equal to 1 over 4, negative 1 over 4. So T3 is just AR squared, remember, is 16, and T6 is AR to the power of 5, that is negative 1 over 4. So if I divide AR5 by AR squared, I get negative 1 over 4 divided by 16. And now A's and A's cancel out. R5 divided by R squared is R5 minus 2, that is 3. Divided by negative 1 over 16 times 4 is 64. So now when I take the cube root of both sides, if you remember, 64 is 4 to the power 3. So I'm going to get 1 over 4, negative 1 over 4. That is going to be my R value. So what is going to be my A? Well, I can substitute it here now. AR squared. R is just negative 1 over 4 squared is 16. So A times 1 over 16 is 16. So A is 256. And the sum to infinity is just A divided by 1 minus R. 256 divided by 1 minus of minus, so 1 plus 1 by 4, right? Minus of minus is going to give me a plus. So the denominator is just 5 by 4. So it's 256 times 4 divided by 5 if you simplify. And that gives you 204.8. All right. Question 11. The first three terms of a geometric progression. So I know T1 is 135. T2 is just K. And T3, the third term, is 60. Given that all the terms in the progression are positive, so we know that R is bigger than 0, find the value of K and the sum to infinity. All right, we know that T2 divided by TR gives me the common ratio. So K divided by 135 is R, and T3 divided by T2 is also the common ratio. So now I get that K squared, if I multiply these two, cross multiplication, gives me 60 times 135, 8100. So K has to be equal to, and remember, all the terms in the geometric sequence are positive, so we only want the positive answer. So K has to be equal to 90, I believe. What is the sum to infinity? Sum to infinity is just going to be, well, now I can use my found value of K to calculate R. So my R is just going to be 60 divided by 90, right? T3 divided by T2 gives me R. And that is just 2 over 3 is R. So sum to infinity is just going to be A divided by 1 minus R. So divided by 1 over 3. So 135 divided by 1 over 3 gives me 405. So the answer should be 405. All right. Question 12. The first three terms, again, is the same type of question. So we can use the second term divided by the first term should equal to the common ratio, and the third term